Okay, guys, I need you to make sure that you complete the following things today for me to make sure that we don't fall off track because we will be having our test that Friday before our February break. Okay? So, first of all, the homework answers are posted as a PDF under today's date on the website. There's also under today's date a PDF of what we would have used as our class worksheet. And if you have a printer, go ahead, pause the video and print that worksheet now because that's what we're going to be working off of for today's lesson. If you don't have a printer, just work out the problems in your notebook. I will be checking that the work is completed tomorrow, so make sure that you do what you need to do, okay? I also have a reading assignment for you with a practice problem. All right, so remember yesterday we were building our confidence intervals and we were trying to capture the true proportion. We knew our sample proportion and we were building intervals with a certain amount of confidence. When we built our interval, we would reach out a certain amount. If we wanted to be 95% confident, remember we used our critical z-score that went with 95%. Now here we're going to be asking a little bit different of a question. So they're saying suppose a candidate is planning a poll and wants to estimate voter support within 3% with 90% confidence. How large of a sample size does he need? So now we're asking about the size of our sample. What you want to think about here is, remember yesterday we talked about when we were building our confidence intervals, we were adding and subtracting our margin of error. So here, when we do this estimate, we want to be within 3% with 90% confidence. So we have a 3% wiggle room, our margin of error here. So our formula that we used for margin of error yesterday was our critical z-score times, remember we use standard error instead of standard deviation. Okay, and that was square root of p hat times q hat over n. Okay, in this problem, our margin of error is 0.03. And we know, remember yesterday we talked about some of our special critical z-scores. If we want 90% confidence, that value was 1.645. And that's going to be over, we need a p hat and a q hat. We don't know our n, we're trying to find our sample size. Now the thing is, for this problem, they didn't give us anything to go off of, any type of, reliable sample to use. So if we don't have a sample that's given, we're going to need to be on the safe side and estimate the largest sample size we would be able to use. So here, if we want to do that, we're going to set our p hat at 50%. That's going to maximize our sample size. Now think about it. If our p hat is 50%, then our q hat also has to be 50%. If we have a sample size that we could actually use, like in the next one they're going to give us one that we can use from a national survey claim, we would want to go with that so we could have a smaller sample size if possible. Because remember, the bigger the sample, the more money we have to spend. Now, what you want to think about here is we have everything filled in, and now this is just an algebra problem. But lucky for you guys, your calculator can actually do this algebra problem for you. So what I'm going to have you do is I'm going to have you pull up your calculator And I'm just going to add a new page here so it's nice and clean. I do not have the CAS version of the calculator, so yours is going to look a little bit different. So when you go to menu, you're going to go to algebra, and then yours is going to say actually solve instead of numerical solve. Okay, and you're actually going to type that equation in. So you're going to do 0.03. You have an equal sign on your calculator. Okay, and then if you see here, there's things in like light blue. To get to the light blue, you'd press like control. So if I want the radical or if I want like a fraction here, I'm going to do that. Oopsies, I went outside my parentheses. So then I have 1.645 times, and then I have my square root, my fraction, 0.5 times 0.5 over, and then you're going to use, I'm going to use x here if my calculator wants to behave itself. Maybe I won't use x. Maybe I'll use n. Okay, and then you want to make sure that you click outside of that radical. Then you're going to use the comma. You have to tell the calculator what variable it's using. So I'm going to use n. I'm going to close my parentheses, enter, and I get 751.674. Now, what you want to keep in mind is you don't want, a fraction of a person. So when we go to take our sample for this, we're going to round it up to 752. So we're always going to want to round up here. Okay, so let's take a look at this next one. We have a national survey that claims that 23% of its online users use Twitter. You'd like to estimate the proportion of adults in New York State who use Twitter. What sample size would you use if you'd like to estimate the Twitter usage in New York within 2.5% with 98% confidence? So when we look here, we want to kind of dissect what they gave us in the problem. So they did give us a value we could use as our p-hat. They also are saying what they want to be within, so this is going to be our margin of error. And they are giving us something that we're going to have to find the critical z for, but this is not one of those ones that is like a common one, so we're going to have to find that by hand. We're going to have to work backwards. So right now, if I set this up, I know that my margin of error is equal to my critical z times the square root of p-hat times q-hat over n. Okay, so I want to be within 2.5%, so I'm at 0.025. We're going to need to work backwards to figure out what this critical z is. So think about the fact that if we shade in 98% here, I'd be left with 0.01 on each side. So I'm going to go to my calculator and I'm going to do inverse norm of 0.01. So menu, probability, distributions, inverse normal of 0.01. Okay, so let's go like 3 places here. So negative, well, actually we're not going to use a negative, we'll just pull this right here, 2.326. Okay, so we're going to toss that in there. let's see, where'd my thingy go here? There we go. So we have 2.326, and then it's the square root of our p hat that we're going with. They gave us 23% of people who use online users use Twitter is their claim, so that would leave 77% that do not use Twitter. And then we're trying to figure out what our sample size is. The minimum one, if we want to have 98% confidence and be within 2.5%. So here again, for this one, we're going to toss it right into our calculator, and you're going to use the solving skill. So you're going to go menu, algebra, yours says solve. Maybe yours will come up when you click it. Let's see if it wants to cooperate with me. There we go. So we have 0.025 equals, and then we're going to do 2.326, and then we're going to get to our square root here, and then we're going to put in a fraction, and it was 0.23 times 0.77, and then we're going to put in our variable and comma. I used n, so I'm going to say comma n. Okay, so my calculator is telling me that I would need 1,533 and 0.06 of a person. Remember, we need a whole person, so this is going to be, we're going to round this up to a 4 here. So I'm going to have my n as 1,534 people. Okay? All right, so what I'd like you to do right now is I want you to pause the video, and I want you to try to work out number 3 part A for me. All right, people, at this point, you should have tried the question. So remember our margin of error formula, and we wanted a margin of error of 5%. So we're going to do 0.05 equals, they're talking about 95% confidence. So remember, that's one of our favorite critical z-scores that we know by heart already, hopefully. That's going to be 1.96. They do not give us a value to go off of. There's no sample proportion, so we're going to have to max it out and go with a 50-50. So 0.5 for p hat, 0.5 for q hat, and n is what we're trying to find. When we put this into our calculator and use the solving skill, you should get something like 384.16. And remember, we don't want a fraction of a person, so we're going to have to round up to 385. Okay, so what I'd like you to do now is I want you to go to the back of the sheet, and they actually now are going to conduct a study, and they give us a sample of kissing couples and how many of them lean their heads towards the right. Okay, and then they want us to determine and interpret the 95% confidence interval for the proportion of all kissing couples who lean to the right. So what I'd like you to do right now is please pause the video and go ahead and work that out. Okay, so at this point you should have written out all your work nice and pretty for this. So first we need to show our think. It's not random, but hopefully our sample is representative of the population. It's plausible that the directions of heads, whether they lean to the right or left, is independent from couple to couple. And the 10% here, 124 is less than 10% of all kissing couples. And then our large enough condition, make sure that you are using p hat and q hat here. Okay, we don't know our true proportion, our p. That's what we're trying to estimate. So make sure you're not being a bobo dum-dum and accidentally putting in a p without the hat. Don't forget your hat. Okay? Now, one like little detail here. It's kind of good habit to get into to wait until the very end when you actually know that it's greater than or equal to 10 to actually write that inequality there. So this works, so we may proceed. So next, remember, you have to state the name of the thing that you're doing. So the thing that we're doing right now, we're doing a 1 proportion z interval. We want to show our work. So remember, our formula was our p hat plus or minus our critical z times our standard error, p hat times q hat over n, square root the whole thing. This is one of our confidence levels that we already know our critical z for, so this is going to be 1.96. If you're not into writing this as a proportion and you want to make it a fraction, that's fine. So yours is probably somewhere around like 0.645. Remember, we can actually use the calculator to do this for us. We just show our work so we know, so the person looking at it knows we know what we're doing. When we go to our calculator, we're doing a 1 proportion z interval. Remember, that comes out of the statistics menu when you have a calculator page up. Our successes is 80, our sample size is 124, and we're using 95% confidence, which is the one that comes up automatically. We click OK, and this is what comes up on our screen. Okay, so we record our interval. I went to 2 places, so 0.56 to 0.73, and then our tell, we need to actually make a statement here. So I'm 95% confident that the true proportion of couples who lean right while kissing is in the interval 0.56 to 0.73. Now for part C, they're asking us to really do the same type of thing, so there's no reason to recheck conditions. But we do want to show our work here for the 90% and the 99%, and really we should have a nice sentence for each of these. So the only difference is our critical z value. Okay, so our 90% confidence should be a little bit smaller of an interval. Okay, if we're 99% confident that we captured the true proportion, we just cast a much wider net. We have a greater critical z. Okay, now they're asking us, is the sample proportion of 0.645 in each of our intervals? Now that's not something you should even have to think about, because 0.645, that's basically our p hat. So we made these intervals from p hat, so of course it should be inside of our intervals. Okay, the next part is they kind of ask us to like think about whether it's plausible for certain proportions to be true. So if there's somebody that's saying, all right, well, I think 50% of all kissing couples lean to the right, you want to go ahead and you kind of want to like look at your proportions you created. And when I look at these, you know, even when we were 99% confident, it went from 0.53 to 0.70. 50% is not even inside that interval. So that's definitely garbaggio. We don't agree with that. When we look for 2/3, that's, you know, 2/3 is like 0.66-ish. That exists inside all of these intervals. So that's something that could be plausible. That makes sense to us. 3/4 is 0.75. So not so sure depending on what your confidence level is, because if we look here, when we go to like 95 and 90, it doesn't really fit inside our confidence level, so I'm not so sure about that. Okay, so at this point, I'd like you to go to your textbook and do your practice problem, and I expect to see this completed for tomorrow. Have a great day.